Hello everyone, this is a short video about digital elevation model. So we're just going to introduce what is digital elevation model is all about in this short video. So what is digital elevation model? Most of you maybe you already know about it. So this is a digital representation of land surface elevation which respect to any reference datum. So this is a representation, this digital elevation model in which or raster representation, can you say, you may say, where we can have a elevation uh, data. Okay, so a DM is, or digital elevation model, is defined as any digital representation of continuous variation of relief over space, where relief referred to the height of the earth surface with respect to the datum considered. So DM are used to determine terrain attributes such as elevation at any point, slope and aspect. So from DM we can actually identify many terrain features like drain basin, channel network, all those things. So it is a very useful data that can be used in hydrology, geology, hazard, natural resource, agriculture management, everything. In case of hydrological application, DM includes all the groundwater modeling. It helps in estimation of volume of proposed reservoir, determine the landslide, flood prone area mapping. So you can see the DEM is very important data, and because as the DEM, through DEM we can understand the elevation of the land surface, earth land surface. So it is very important for many applications. Okay, and in many mapping area, or in many other thing like any other kind of modeling also you can use DEM. So DEM is very important data raster data set. So let's see, this is my raw DEM data. Okay, this is one of my raw DEM data, and this is I have just sliced it. I just made density slice here. I did. So you can see the lowest height over here is minus 43 and highest is 62 meter. So this is the area represent where the lowest height is minus 43. Minus 43 means that it is below the land surface. Okay, minus represent below the land surface. So this is the minus 43 means there is a height, or there is a features which have a height or elevation below the land surface. Okay, so now let's see what is the difference between the DEM, DSM and DTM. In case of DEM, which represent the bare earth surface. What does mean the bare earth surface? Our earth surface is consist of all trees. Okay, we have build-ups, we have all those things, right? But in case of DM, it will only represent the ground, not the trees height, not the build-up height. Okay, so this is a so this can be used to for contouring or of topography or relief map. Now the question may come: the mountain or hill comes to a like, would they show the hill and mountain also in them? Of course, it will show the hill and mountain. What it won't represent is the tree on the mountain or tree on the land or the build-ups. Okay, but it will show the elevation of the earth surface. The mountain itself is it count inside the elevation of the earth surface. Okay, the earth surface have folded or uphilled, that's why there is a mountain, right? But tree is a different story, so it won't represent tree or build up in case of DEM. Now coming to DSM, what is DSM? In case of DSM, it will represent all the natural and build up or artificial feature of the environment. Okay, this is also 3D representation. Like it will show it in this case, in case of DSM model, it will show you if there's a tree, it will take the height of the tree. If there is a build-up, it will take the height of the build-up. Okay. And what is DTM then? DTM is digital terrain model, which is which is just like DEM, but in this case it include vector features such as river, ridge, all those things. So DEM is representing bare earth surface, DTM represents bare earth surface including river and ridge. Okay, we generally use DTM. In many cases, in many projects, you will see they are using DTM instead of the DEM. So from DTM we can interpolate to generate DEM, but not from DEM. From DEM we cannot. From DEM we cannot generate DTM. Okay. So let's see. For the more clear idea, let's see one example. So in this example, you can see there is a build-up, there is a forest, and if you can see, there's a 3 line. Okay. So this black line, if you see, this black line is a representation of DEM. This gray line is a representation of DSM, because as I said, DSM is going to represent if even there is a build-up height also and tree height also. And this orange is DTM. Okay, so it will like DM, it will not represent the height of tree or build-up. Okay, so there are three type of DEM. One is regular square grid, one is triangular irregular network, another is contour. What is grid structure that we generally see? There will be a raster, gridded raster. So the gridded DEM consists of regular placed uniform grid with elevation information of each grid. So just like your raster data, it will have the row columns and each cell. That cell here we call grid, and this grid will have a information of elevation. Okay, so each grid will have a information of the elevation. It's just a simple matrix. You can see it here. So if this is my DEM data, this is my x, this is my y, and this is my height and information. And this here in raster we say that cell, but in case of DEM we call it grid. Okay. Now what is tin? Tin is using a irregular sample point connecting through the non-overlapping triangle. The vertex of a triangle match with the surface elevation by sampling point, and triangle represents the plane connect the point. So there will be points. From these points they are drawing a triangle, and each triangle through the point is connecting to each other. Okay, so that is how it is creating a dense network of triangle. Contour based structure. Contour based structure. What is contour? Contour represent point having equal height or elevation with respect to the particular datum. So in case of DEM, where there is an elevation, so there can be a places which has a same elevation. So contour will represent points, okay, having the same, like it will join the same point or equal height point, and it will draw as like that. And suppose uh, this is my contour. Okay, so this each line is representing a particular elevation. So wherever they have, suppose this is a lot of points here. So this point maybe it's representing 1,000 meter. So this whole thing is 1,000 meter. So it is joining those points. These lines are joining those points which have the same elevation, that is 1,000 meter. So this will, if it is 1,000 meter, maybe this is a 900 meter, okay, or 950 meter, depending on the interval of the contour. So this line actually representing or joining the points which is having same elevation or height, right? So this is the whole thing of DEM contour based structure. Now coming to the source of digital elevation, there are many sources, you can see it from here, and there are a lot of other application of DEM. And this is just an introduction, what is DEM, what is DSM, and what is DTM, and what are the type of DEM. We will not going to go in the details here, because detail we will do that in our classes. So this is just an introduction to the DEM, digital elevation data. Okay, thank you so much.